Welcome to Space to Ground. I'm Chelsea Bayarte. Earlier this month, a SpaceX Dragon cargo spacecraft delivered scientific experiments and new rollout solar arrays to the International Space Station. And this week, it completed its mission with a splashdown back on Earth. It was the 28th cargo resupply mission for SpaceX. The spacecraft undocked from the Harmony module on the space-facing side of the space station on June 29th and made a parachute-assisted splashdown off the coast of Florida June 30th. But it didn't return to our planet empty-handed. A number of experiments and samples were on board, returning back to Earth after collecting data in microgravity. Speaking of making a splash, this week NASA astronauts released a wave of mini satellites into orbit. One is called ESSENCE, and it can be used to study the thawing of ice and permafrost in the Canadian Arctic, among other things. But don't take my word for it, take it from the student researchers themselves.
So the ESSENCE CubeSat mission's purpose is to monitor climate change by using the wide-angle camera, which we have on board, to monitor the thawing of the permafrost in the northern Arctic and Canadian region.
There's also a proton detector on board, which is going to detect solar energetic events happening in the lower Earth orbit.
Inside the International Space Station, plants continue to grow, and this week NASA astronaut Woody Hoburg will tend to them. The experiment is called Plant Habitat 3, and it's studying the second generation of plants using seeds previously produced on orbit and returned to Earth. When exposed to the stress of spaceflight, plants may undergo genetic changes from one generation to the next. Results from this study could provide insight into how to grow generations of crops to provide food to astronauts on future space missions. This experiment is a follow-on to the Plant Habitat 2 experiment that studied how different types of soils and light affected the growth of radish plants. And yes, the astronauts got to eat the radishes and report on the taste when they were done. Just last week, researchers announced the environmental control and life support systems aboard the U.S. segment of the space station can recover 98% of the water delivered to the space station. Before the upgrade, total water recovery was more like 93%. Two pieces of hardware helped achieve this goal: the urine processor assembly that recovers water from urine, and the brine processor assembly that can extract the remaining wastewater. Reclaiming water is important because each astronaut needs about a gallon of water per day for drinking, food prep, and hygiene. As the astronauts say, yesterday's coffee becomes tomorrow's coffee. That's Space to Ground for this week. Thanks for watching.